Hello everyone, we are Team 61. Our project is Book Recommendation Engine. So basically, we are building a recommendation system to do three kinds of recommendation. The first one is recommend new books to customers. This includes recommending books to the existing users based on their tastes and recommending reading lists to new users based on books' popularity. And the second recommendation is to recommend friends to users based on their similarities on books. And the third recommendation is to recommend potentially useful reviews. And finally, we will visualize these findings through System G and our web application. These are technologies we use in our project. So we used all the technologies we used from this course, including Mahout, Spark, and System G. And also we used some libraries in Python such as Flask. And we use Amazon Books Review dataset. It's about 9 gigabytes and containing almost 9 million reviews. This is an example of the dataset. We can see it concludes the reviewer ID, which is user ID, and this is item ID, reviewer name, helpful information, and the review test, and the overall is rating, and also a summary is some summary test information and the time information. In our projects, we met some challenges, and to summarize, there are many about the dataset is too large to fit in any one of our memory. So for example, we cannot just simply use pandas or R to load the whole dataset. So our solution is to use Spark data frames, which does not consume too much memory. And for recommending friends to users, firstly, we hope to use one-hot encoding and do clustering, but later we found that the one-hot encoding matrix are too large. So instead, we use user-based recommendation in Mahout to compute the user similarities so that we can rank them. And also, we found that the Spark data frames are not as flexible as some other data analysis tools such as scikit-learn, but we can easily use Lambda functions to realize our functions. And then we come to do some data analysis. To recommend books for users, we first focus on ratings. From this distribution, we see that the majority customers will rate 5 stars. And from this chart, we see that most books have an average rating over 4 stars. So from these two charts, we see that it's hard to just simply recommend books by their ratings. So that's why we come to Mahout Recommender. We tried user-based recommender and item-based recommender. For this dataset, user-based recommender does not work as well as item-based recommender because the number of customers is far larger than the number of books. Also, some customers have little preference and it's hard to find a user neighborhood for them. For item-based recommender, we tried the Pearson correlation item similarities matrix and the Euclidean distance similarity matrix. And we evaluate them using average absolute distance on the test dataset. We can see that the Euclidean distance similarity matrix outperforms Pearson correlation-based similarity matrix in this case. Here are some recommendation results. First is a book recommendation. Each line is a recommendation for each user about the top 5 books. And then it's a friend recommendation result. We see for each user, we recommend the 5 nearest neighbor for them. And then we come to the third recommendation, which is to recommend potentially useful reviews. So we first classify reviews into 2 categories, the helpful reviews and the unhelpful reviews. based on the helpfulness votes of customers. Then we study roughly word frequency for each category. From these two word clouds, we found helpful review usually contains more quotations from the book and other readers. And then we come to the classification method. We build a Spark pipeline to do our project, where the input is review data of our test. We split the test to word arrays and remove stop words, use term frequency hashing, and add rating features, and add positive negative rate from positive and negative words dictionary, and do label indexer, and then we tried both naive Bayes classifier and logistic regression classifier. And here are the results for our classification. The accuracy for both naive Bayes and logistic regression are about 65%. And here are the normalized confusion matrix. We visualize the clusters of similar users in System G. There are two examples consisting the users and his neighbors with depths of 2. This is the first example, and this is the second. And from this graph, we can see that System G can show users' popularity. Users with larger degree are shown with a larger size in the graph, and also more likely to be neighbors for other users. We can use this characteristic to recommend users for new users. And then it's our web application of book recommendation engine. In this engine, we can recommend books and similar users according to his or her taste for books. And now we're going to show how we can run our web application in terminal. First, we need to execute our Python program, and it may take a few seconds to start. And then we copy this URL to a browser, and it shows our recommended web application. There are some pages in the menu bar containing information about the project and also about us. We can start our recommendation engine in the sign-in page. For example, we can enter one of the existing users. Let's say start with A, or we can use this one. And we click the start button. Because we scrap the book's user's image and name information from AppZone in real time, so it may take a few seconds to see the recommendation results. And here we go. We see we recommend the top 5 books and also top 5 friends for this user. And if we click one of the books link, we can go to the AppZone page, and we can see the information about this book. And we go back. It's same for the users. If we click the link of one user, we can see the user information. We can see the reading history and the rating history. And also our engine can recommend books and users for new users. We can input an ID that does not exist in our database. For example, we can randomly input some ID like this, and we start. The engine will randomly recommend 5 most popular books and 5 most popular users for this new user. We see these 5 popular books and 5 popular users. In the future, we hope to build a larger online database which can store the information of users and books to promote the recommendation speed. So in conclusion, our project has built a web application realizing three kinds of recommendation. The first one is to recommend unread books to users. The second one is to recommend users with similar tastes. And the third one is to recommend potentially useful reviews to users. And we can do something in the future to improve our projects. For example, for recommending friends to users, we can build clusters with classic method and recommend more explicit identified communities. And for recommending useful reviews, we can do more feature engineering and hyperparameters optimization to improve our prediction accuracy. And also for our web application, we can add the reviews recommendation part. So that's all about our project, and thanks so much for listening.